गुड मॉर्निंग स्टूडेंट्स। कैसे हैं आप लोग? आई थिंक यू आर फाइन. In this video, we will discuss about solid, their structure, their type, and the application of the solids. So let's start. What is solid? Solid is a substance which have fixed shape and fixed volume. The intermolecular force between the molecules is very less and the density is very high. The solid state drives or SSD are the type of a storage device that are used in integrated circuit to store data persistently. They are the use of the semiconductors. They are known for their speed, durability and low power consumption compared to the traditional hard disks. HDD are becoming increasingly popular as the price of flash memory has decreased. HDD are also more resistant to physical shocks and vibration than HDD hard disks. So these are the use of the solids. Now, solid is of two types. One is called crystalline solid and second is called amorphous solid. Crystalline solids have highly ordered and repeating arrangement of atoms, ions or molecules. This arrangement forms a crystal lattice which is three-dimensional framework of repeating unit called unit cells. The arrangement of these units is responsible for unique property of crystalline solids. Crystalline solids are anisotropic in nature due to their order structure. Crystalline solids exhibit anisotropy, meaning the physical property varies depending on the direction in which they are measured. This is because the arrangement of atoms or ions in the crystal lattice can influence how light, heat or electricity travels through the material. Crystalline solids have a sharp melting point. The melting point is characteristic property of each crystalline solid. Amorphous solid. Crystalline solid have highly ordered arrangement of constituent particles, but the amorphous solid lack a long range order in the arrangement of constituent particles. The atoms or molecules are randomly arranged in amorphous solids. Some examples of amorphous is your glass, rubber, plastics. On other hand, the example of crystalline is your diamond and quartz and salt. So, solid, different types of the solids like van der Waals force, hydrogen bonding and dipole-dipole force. Van der Waals force are weak attractions. They are responsible for attraction between the non-polar molecules. They have low melting point, low boiling point. Hydrogen bonding is a strong dipole-dipole interaction. This type of interaction leads to the high melting and boiling point compared to the van der Waals force. Examples are water and ethanol. Dipole-dipole interactions between the two dipole polar molecules. These interactions are strong due to the charged particles. Then the van der Waals force and hydrogen bonds also. This type of interaction is present in the molecules like hydrogen chloride and carbon dioxide. Now, ionic solid and metallic solid. Ionic solid are characterized by a strong electrostatic interaction between the oppositely charged ions like positive ions and negative ions. These ions attract each other due to the strong electrostatic force. This strong attraction leads to the high melting point and boiling point. Right? And they become good conductor in a molten and dissolved state. But metallic solids consist of lattice of positively charged ions surrounded by a sea of delocalized electrons. These valence electrons are free to move throughout the metals and that's why they are excellent in electrical and thermal conductivity. Examples of ionic solids is your sodium chloride, calcium hydroxides. On the other hand, metallic solids use copper, silver, gold. These are the good example of metallic solids. We all know that copper, silver and gold are the good conductor of heat and electricity. Next is your covalent and network solid. Covalent solids are held together by a strong covalent bond. Network solids are the type of covalent solids where the covalent bond extends throughout the entire structure. Right, the properties are covalent and network solids typically have a high melting point, hardness and poor conductivity. They are very good brittles, which means they will the property makes covalent and network solid is suitable for application that requires strength, rigidity and resistance to heat. So these are the application of your covalent and network solid. Now, crystal lattice and unit cell. What is the crystal lattice? A crystal lattice is a three-dimensional arrangement of a point representing the position of atoms in the crystal. It's a geometric framework that helps visualizing the repeating pattern of particles in solid. Unit cells is a smallest repeating units of a crystal lattice. Type of unit cells. There are different type of unit cells based on the arrangement of atoms and within a them. Primitive unit cells. Center unit cells. Primitive unit cells are the simplest type of unit cell. They contain only one lattice, one point per unit. This means that each corner atom is shared by 8 unit cells. On the other hand, centered unit cells, on the other hand, contains more than one lattice point per unit cells. This can be achieved by placing additional atoms at the center of unit cells. Example of the centered unit cells includes the body-centered cubic and face-centered cubic unit cells. Now, packing efficiency of cubic close packing. Cubic close packing (CCP) is the type of crystal that found in many metals. The structure is characterized by close packing of atoms in cubic unit cell. The packing of efficiency of CCP is calculated as a ratio of volume occupied by atoms to the total volume of the unit cells. The packing efficiency about nearly 74.05%. This represents the maximum possible packing of a sphere in three-dimensional space. There are 12 each atom is in contact with the 12 other atoms in these unit cells. Packing efficiency of body-centered cubic cells. So these are the formula. Body-centered cubic structure is commonly crystal structure in metal like iron, chromium, tungsten. It's characterized by its packing of efficiency, which is measured of how closely the atoms are packed together in a structure. To calculate the packing efficiency, we first need to determine the volume of unit cells and the volume occupied by the atoms. So these are the formula we can use to calculate, and after calculating we get the packing efficiency is about 68% in this type of arrangement. The simplest cubic lattice is the simplest of the three common cubic lattice. It consists of atoms arranged in a cubic shape. The low packing, and in this packing there is a 52.4% only there is a packing efficiency. The low packing efficiency of a simple cubic lattice is due to the fact that the atoms are arranged in a loose open structure. This means that there is a lot of empty space between the atoms. The simple cubic lattice is not very common in nature. However, it is still important lattice type as it provides a basic understanding of the structure of the solids. Now, application of the solid. Solid play a crucial role in various fields and application. The unique properties and structure make them essential component in numerous industries, from the construction of building, bridges to development of the advanced electronic device, solid and ubiquitous in our modern world. Their diverse property including strength, hardness, conductivity and optical transparency make them indispensable for wide range of application. So this is all about in this video. So in this video we discuss about the solids, their structures, their packing efficiency, and the application of the solid. In next video we will discuss about the defects which are present in the solid. Thank you. Have a good day.